We are on the page 23, sections 9.8 and section 9.6. Okay, solving quadratic inequalities and solving rational inequalities. This is one of the miscellaneous things we are learning. And so far, okay, first thing we are learning is to graph the quadratic functions, right? And other things. And now we are doing some miscellaneous things relate to the quadratic function, okay? We are going to do solving quadratic inequalities first. So, what are quadratic equations? We talk about those. Quadratic equations means what? Second degree polynomials equals to 0, right? In standard form, we write this way: ax squared plus bx plus c equals 0, right? Then quadratic functions are things, the function leads you from x to y, so y is your result of the function of f of x, which is quadratic, right? Second degree polynomials is in the form of this, right? So, let's see. Then what do you think is quadratic inequalities are? Okay, so let's go back to review. We did this in your 152A class to solve linear inequalities in one variable. Let's just talk about one variable first, okay? So linear means what? A line, right? And linear inequalities. So let's look back, talk about inequalities, okay? We talk about linear inequalities. So what are linear equations first? What are linear equations? Which look like x plus 5 equals 7, things like that, right? That's the equation. Just one variable polynomials in one variable with what? First degree, right? So then linear inequalities would be what? Things like this: x plus 5 bigger than 7 or bigger than equal to, less than equal to, right? Then we have to find our x. So for linear means what? First degree. Right? In one variable. So when we try to find the inequalities, so let's make it simpler. If I minus 5, so I have x plus 5 greater than 2. Oh, not x plus 5 anymore, x bigger than 2. So to solve the linear inequalities in one variable, the x is not only what? One answer, right? It may have many answers. So we say, what do we do to answer the question? And for all the x's, so your x, so we did it by graphing, that's 2. All the x's on those pointing on, all the answers, right? That's one way to show. Another way to show is what? With interval notations, right? 2 to infinity all the way, right? Also, if we use the set symbol, formally you might see it on the computer. You have x, then you put a bar there to describe it behind it, then put in a set. Because there are infinite solutions, you cannot say, oh, x equals something to answer the question. So you have to use other ways for the inequalities, right? So we did this in 152A class for linear inequalities in one variable, right? So what do you think? We are going to talk about nonlinear inequality. Linear means what? A line, right? Nonlinear means not a line, means the line has bended. So it would be what? Nonlinear inequalities is like, okay, second degree, things like this, or third degree, right? Then for inequalities, if we write a formula for the quadratic inequality, nonlinear can be not a line, can be second degree or third degree, okay? So if we do nonlinear would be what? Higher degree, more than one, right? Then if we do quadratic inequality, that's what we are going to do, okay? So what is quadratic equation? Quadratic equation would be this way. Standard form, ax squared plus bx plus c equals 0, right? Second degree. Then quadratic inequalities, what do you think? That will be ax squared plus bx plus c can be bigger than 0, bigger than or equal to 0, or less than 0, or less than or equal to 0. Right? So we are going to solve this type of a problem. What are x's? That was the question, right? For linear, you know how to solve it. Just solve it like what? Equation, and isolate your x, right? Now, for second degree, it's not as straightforward. Okay, so let's see how we are going to do it. So let's see some examples. So if I have x squared plus 2x plus 8, solving it is not too bad, but understanding it is a little bit confusing. Okay, so if we have questions like this, what was the question? And what's the answer you need? It means what? What are our x's? Right? Can fit in this situation. Just like a linear, you might have many answers. So you have to use the graphs or interval notations to show. We are talking about in one variable right now for x. So x squared plus 2x bigger than 8. Can x be 1? We are just guessing right now. 1 plus 3. 1 plus 2, 3. Not. Right? 2, not. 2, not. It's equal to 8. Up to 3, maybe okay. All right? 4, it's okay. many of them. But how can we find it? So is this the same situation as your minus 8 on both sides? Is that same thing, right? Then what are those x's? So besides how we are going to solve it, let's visualize first, okay? How we are going to visualize it? We use what we have learned earlier. Let's see, we do it this way. So this value has to be bigger than 0, right? So if I call this 0 value is y, I write it this way. Okay? Then what do I need to do? Then this whole thing has to be bigger than 0, right? That means what? My y has to be bigger than 0, right? Because this, I use y to represent that. Right? Then, if I wanted to visualize it, I can graph it, right? You know how to graph y equals, a quadratic function. That's quadratic function, right? We just learned how do we graph it. Then we will use our t-table, x and y. Y is x squared plus 2x minus 8. So, which point we are going to put it in the middle? What do you think? We just learned the property for a quadratic function. It opens up or opens down? Opens up, right? So it opens up, it has a what? Minima. Then that's your vertex. Then what's our vertex? We learned the property is what? X equals negative b over 2a, right? B is 2, so negative 2. 2a is what? 1. So your vertex is x is negative 1, right? So you put it here in the middle, negative 1. Then you plug in negative 1, 1, minus 2, minus 8 is what? Negative 9, right? So we can graph it. Negative 1, negative 9. That's your vertex, right? Then we'll find the other points. Oops, that's 1, negative 1, negative 2, negative 3, right? So I have negative, 0 would be negative 8, 1 would be negative 5, this one would be negative 2, would be negative, should be symmetric, right? So we have 0, negative 8, 1, and negative 5, maybe a little bit higher. Here would be other points, right? So that would be your parabola, right? Okay? So, if I extended more points, I have 2 and negative 4, then I will get 0 here. So I just make more points. So that would be 2, 0, that would be negative 4, 0. Right? So, what do we try to do? What was the question? To find the x, which will make x squared plus 2x bigger than 8, or x squared plus 2x minus 8 bigger than 0, right? Which is the y value represent this second degree polynomials. All right? So if you look at the graphs, what's your y? Up and down is your y, right? Then we want to find the y value is bigger than 0. That means y value is here. Are those your y value bigger than 0? Right? Up, here, up. Okay, y value is bigger than 0, but that wasn't the question. What was the question? Question is, what's the x to have this value? That means for those y values bigger than 0, what's the x will make it happen, right? So all here is what? X and y's, right? Then y is bigger than 0. What's your x? Just by looking at the picture, visualize it. That's what we are doing, right? That means as long as x is bigger than 2, from here on, bigger than 2, 3, 4, then your y value will be bigger than 0. So your answer should be what? X is 2. Can it be 2? 2 is 0. It's not bigger than 0. So it's bigger than 2 to where? Infinity. All those points for x, your y value will be bigger than 0. How about this side? As long as x is smaller than -4, you plug in, y will be bigger than 0. So you have what? Negative infinity to -4. All those points for x will be, your x will make the y bigger than 0, will make this second degree polynomial bigger than 0. So when you put it together, that would be your answer. Is that right? Okay, so we just visualize it. Okay, but when we actually do it, we don't do it this way. It gets too complicated. So doing that actually is much easier. All right, so look your page 24, the solving the examples, okay? We said, all right, this is the third part, so solve this one. Are they the same? Same questions. Okay, find the x. So the actually doing that is this way. So first step, what do? We write it in standard form. Okay, move this to one side. Then we do what? Write it in, so first we write it in standard form. Then we need to find the critical numbers. Look at that. It's -4 and 2 critical numbers because it will make the situation, the y, the whole thing, either bigger than 0 or less than 0, right? So we call those 2 points called critical numbers. So to find the critical numbers, is the boundary condition. So when it's equal to 0, okay, when it's equal to 0, one side will be bigger than 0, another side will be less than 0, right? So let's find the critical numbers. When we put the equals there, means we find the equation, all right? So you change inequalities to inequalities to equations to find the critical numbers. Okay, so I'm just looking the previous page, 23rd, the steps we wrote for you. Step 1, write the inequality in standard form and then solve the related equations. So write in standard form, then we write the equations, right? Then we solve it to find the critical numbers. So you can factor it, will be plus 4 minus 2, right? So this one, x is what? Negative 4, x is 2. So those are your critical numbers. Look at that, negative 4 and 2, right? Okay, then second step, and we call it what? I try to find it. The name we usually use. Okay, so, we call this line graph. So we do the line graph. Okay, because x, just one variable, we are solving the nonlinear inequalities in one variable. We call it using line graph. Okay, from the line. So you have what? Write down your critical numbers. One is what? Negative 4. One is 2. Okay? 2. So you do this way. So those are your critical numbers, negative 4 and 2. Right? When you plug in to the original thing, that will make what? 0, right? Make it the original x squared plus 2x minus 8. This one will be 0 value, right? Then when you use critical numbers, so you mark how many areas? 1, 2, 3. Split it to 3 areas. Then the answer will be within there, either this part or second part or third part. Okay? Then once we use critical numbers to split it to 3 parts using the line graph, we call it, right? Then next step, look at your page 23. Then for 3 regions, you test them with from the original thing, see which one is working. So that's original thing, say if this one is bigger than 0 or not. Okay, so you need to choose points. Then what do you think? Whichever number is easier. I would choose what? How about negative 5? I would choose 0 here. I would choose 3 here. Just a smaller number to deal with. So if I do negative 5, I'm going to test the original condition. So I plug in negative 5. So I have negative 5 squared plus 2 times negative 5 minus 8. Often, when you test with negative numbers, you make mistakes. Okay? Don't do that. So, test the original one, bigger than 8. We don't have to do the standard form, so we should do this one. Right? And let's check. So let's see, is this bigger than 8? 25 minus 10, 15. Yes. Okay. So if negative 5 test okay, it means everything around in that same region will work. Okay? So all this part will work. How about 0? So you 0 squared plus 2 times 0 bigger than 8? No, that's 0. How about 3? So if it's 3 squared plus 2 times 3, right, bigger than 8? Yes. So this portion, this region, everything will work, right? Then critical numbers separate all those regions because it's 0. One side is bigger than, one side is smaller than, right? So this part will work, this part will work. So what's your answer? This part, interval notation, right? Negative infinity to this number, to critical number. Don't use negative 5, your test point, because all the way to negative 4 can be negative 4.2, 4.3, right? So all the way in union, this part, 2 and up. So that would be your answer. Do we have same answer? Okay, so that's how we actually do it, using a line graph to do it. So what's the steps? Remember the steps, okay? And this one, first you write it in standard form, then you write equations to find your critical numbers. So first find your critical numbers. Then the critical numbers, and on the line graph, number line, then split it to 3 parts, okay, with critical numbers. Then what do? You test them for different regions. Yes, no, yes. So your answer will be these 2 parts. So in general, in your class for second degree polynomials, right, quadratic inequalities, your answer either in the middle or outside 2 parts. Okay? So this is one of the miscellaneous things you are learning relate to quadratic functions. To solve what? Nonlinear, second degree, nonlinear inequalities in one variable. Okay? You need this for your pre-calculus and calculus. You don't need it for, business cal or other things. It's for science major. Okay? So, then let's take a look at another one. So we just solved what? Nonlinear inequalities can be second degree quadratic inequalities. Okay? Let's look at some more examples. Okay, on your page 24, let's do this one. Negative x squared plus 18 less than or equal to 3x. Okay, so what's the first step? Write it in standard form and find your critical numbers with the equations, not the inequalities, right? You need to find the critical numbers with the equations. So first we do that, write it in standard form, right? So it will be 3x plus 18 less than equal to 0, right? Then we will write this in equations to find the critical numbers. So that will be next x squared plus 3x plus 18 equals 0, right? Usually when we factor it, we don't use negative in front. So you will make more mistakes that way. So we just divide it by -1 that way. So we have x squared minus 3x minus 18 equals 0, right? Okay. Then we factor it. Would be x minus 6, x plus 3 equals 0. So your critical number is what? One is 6, one is -3, right? That's your first step. Find your critical numbers. Then you will graph it with line graph to split this to 3 regions, right? One is -3, one is 6. That's your critical numbers, right? Then we are going to test them to see which portion is working. So, third step, okay, you're going to find the areas to test according to it's better use this one, use the original, okay, just in case you have a mistake in the middle. Okay, so which number we want to use? So I probably use the just a -4. This one I can use 0. I can use 7. Right? So I plug in here, plug into the original. So what do I have? -4 squared plus 18 is less than 4. What do you think? 16, -16, that's 2, less than 12. Yes. Okay, how about 0? So you plug in there. So what do I have? -0 squared plus 18. Is that less than 0? No. Okay, so my answer, this portion is okay. And how about here? Here, what do I have? Plug in 7, right? -7 squared plus 18 less than 3 times 7, that's negative 49. -49 plus 18 is less than 21. You better do it because 49 minus 18. So that would be -31. Less than. Usually you make a mistake when you check. Okay? Is that so? Yes. So your answer is either in the middle or the two sides. Okay? Then what's your answer? So next one, you answer the question, which area will work. So from here on, from -3 on, not a -4, right? Up here, so -infinity with parentheses to 3, -3. Do you include 3? -3. Like this one, we don't because that's greater than. But here, you do have an equal sign. If you plug in -3, okay, -3 is 9, -9 plus 18 is what? 9. And -3 times -3 is 9. So it's equal, right? Boundary condition, so it's equal. You have to include the -3. Then for this one, do we include 6? So you plug in, actually they are equal. Okay, so that would be 6 to infinity. You have to include that boundary condition. So the boundary condition make it 0, right? For the quadratic inequalities. Okay, so that will be this question on your page 24. Okay, we want you to solve it algebraically to do it. Okay, not just guessing, give an answer. You do need to practice to see it. Okay, then next one, you have 2x squared minus 15 less than negative 7x. Same steps. Okay, so find the critical numbers by doing what? Write in standard form first. Right? Move over. Right? So we will write plus 7x minus 15. So to find the critical numbers, we need to find the boundary conditions, which is at the 0 point. Right? Either one side is bigger than 0, one side is less than 0. So when you factor it, okay, you need to know how to do the factoring. Okay, it becomes x plus 5. Okay, better not to do that. So, x plus 5 and 2x minus 3. You need to know how to factor it. Otherwise, you won't be able to do the class. So this one is negative 5. This one is what? 3/2. Okay? So after you have critical numbers, then you will do the line graph. Then with those critical numbers, one is negative 5, one is 3/2. Right? For 3 regions. So then what do? The next one we do the testing. Okay? To see the answer is either in the middle or on the 2 sides. Right? So probably you use 0 here, you use negative 6 here, you can just use what? 1.5, so you use 2. Right? So you plug in original 2x squared minus 15 is less than 7x. You plug in your 6, negative 6. Then you plug in 0. Here you plug in 0 will be 2 times 0 squared minus 15 less than negative 7 times 0. 0, negative 15 less than 0. Yes. So this will work. And you test this, will not satisfy the conditions. Okay? So where is your answer? Right in between here. Do you include the boundary conditions? You plug in. That will be what? Equal. This one will be equal. Okay? So your answer for this one is in the middle. That would be from here to here would be what? Negative 5 to 3/2 with brackets. Are we good? Okay, what did we just do? We review the linear inequalities in one variable, right? Then we did what? Finding the solutions for the x's for the nonlinear inequality, quadratic inequalities, right? In one variable. So we just did nonlinear can be what? Quadratic inequalities. Okay. Now we are going to learn another nonlinear. Is called rational inequalities. Okay, so for nonlinear can be what? Quadratic or rational. So what kind of things are rationals? Reasonable. So we say rational means ratio. Okay, so fractions, polynomials in fraction forms, then we call it rational expression, right? So rational, we did this. Rational equations, it's like 1x plus 1x plus 1 equals, is that fractions, right? So rational equations. Then rational inequalities, okay, we are going to do, let's look at the page 25. Let's see some examples. Then we just do the simple one in this class. Then pre-calculus will be more complicated for the inequalities. So those are those things we are going to do are rational inequalities. Okay, so this is a rational, right? Equations. If you put an equal sign, then otherwise we are doing the inequalities. Okay, so how should we start? Same steps. First, you find the critical numbers. Okay, so for your class, you have two critical numbers. For the fractions, what kind of things are critical? All right, denominator cannot be 0, right? It makes difference. So one is when the denominator is 0, it's critical. That's fine. Another one is boundary condition, means what? When it's equal, right? When it's equal, one side would be greater than, one side would be less than. So you have this one, it's easy, solve it. Then another one is what? You have a rational equations. That's why at the beginning we reviewed those from your 152B class, right? Then how do you solve this one? Right? So we say, okay, let's just make the same denominator LCD. So that's a 3. If I make a minus 5 here, I do the same thing here, right? Then if I have the same denominator, I can ignore this because a cannot be 5. Okay, that's critical condition already. So we have a plus 3 equals 3a minus 15. Then you move around. Then you find out your a is 3. You can do that. So first step, you find your critical numbers. Then second step, use the line graph to split it to 3 regions for your class, right? One is 3, one is 5. So I have 3 here, I have 5 here. Okay, then those are your critical numbers. Okay, then next step is the testing. Testing for different regions. Okay, you need to use the original inequalities to check, to make sure. All right. So what do we have? If I have 3, 5 here, I probably use 4 here, use 6 here, use 2 here. Okay? So I'm going to plug in here. What do I have? 2 plus 3, 2 minus 5 is less than -3. So it's a 5 over -3 less than -3. Then you make a mistake. Here, you cannot decide which one is bigger, which one is smaller. Right? You better do better. You need to do better than this to figure out which one is bigger, which one is smaller. Okay? That's a -1 point something. -1 point something is not. No. Okay? Then for this one, so 4 plus 3, 4 minus 5 less than -3, that's a 7 over -1. -7 less than -3. Yes. Okay, so this part is. Then how about 6? So I plug in 6 plus 3, right? 6 minus 5 less than -3. That's a 9, -9, 1, 9, right? 9, -3, no. Okay, so the answer is in the middle. However, when you write the interval notations, you need to check the boundary condition. So can it be 3? Okay, 3 plus 3, 6. 6 divided by -2 is a -3, so it's equal. So this one is what? Equal. So your answer is what? You have to include the 3. How about 5? 5 will make the denominator 0, so you cannot use that point. So not a 5, up to 5. So that would be your answer. Good. So for your class, as we said, okay, your answer is either in the middle or on the 2 sides, right? Okay, let's try another one. If I have x plus 4, x minus 1 less than or equal to 2. So what kind of things we call this? Something rational, right? So it's a rational inequality in one variable. Then we try to find the answer for x. So first, we have to find the critical numbers. So for the rational inequalities, critical numbers, 1 is what? You will make a denominator 0. 1 is what? When it's equal, right? To make one side is less than, one side is greater than. So this one, x is 1, right? This one, you need to solve it. So let's solve the rational equations, right? Have same LCD, ignore all that. So we can do this with 2x minus 2. So your x is 6. Okay. Then what do we do? Second step, we use the line graphs to split to the 3 regions. Okay. So our CN is what? 1 and 6. So I have 1 here, I have 6 here. Okay, and next step, we are going to test the original. Test the original with what? X plus 4, x minus 1 less than 2. Okay, so I'm going to use 0, use 2, use 7, just a small number. So to see if it works. So 0 would be what? Plug in 0 plus 4, 0 minus 1 less than 2. That's negative, so it's yes, right? If it's a 2, I have 2 plus 4, 2 minus 1 less than 2, 6 over 1. 6 less than 2? No. Okay? Then how about 7? 7 plus 4, 7 minus 1 less than 2. That's C. 11 over 6 less than 2. Yes, less than 2. You can just use calculator and find the decimal point. So your answer would be what? This portion outside, right? This portion. Then you have to answer the question considering the boundary condition as well. Negative infinity to this point, right? Critical number 1. Can we include 1? Denominator 0. So we cannot, right? How about this one? 6. You plug in. That's 2. 2 equals 2. So it's a 6. It's okay all the way to infinity. Then you use the union sign in between. Okay, so that would be your answer. Right? So for this section, we are learning one of the miscellaneous things for inequalities, right? We solve what? Quadratic inequalities. And earlier, now nonlinear inequality is what? One is quadratic inequality, one is rational inequalities. So we did the quadratic inequalities and rational inequalities, right? What kind of methods do we use? First, we find the critical numbers, right? Then you make different regions, 3 regions. Then you test different parts, answer either in the middle or on the 2 sides. We keep repeating always, right? Then hopefully you remember them with practice, of course. So this would be your section 9.8 and section 7.6.